Alright guys, so in this equation, I have 2 to the power of m minus 2 to the power of n is equal to 8064. So I want to find the value of m and n. So, because 2 to the power of m minus 2 to the power of n, because this is positive, we know that 2 to the power of m is greater than 2 to the power of n, meaning that m is greater than n, because both of these are the same bases. So I'm going to let m equal to n plus k, and k is an integer. So if m equals n plus k, then I have 2 to the power of n plus k minus 2 to the power of n is equal to 8064. Now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of n plus k, that's going to equal 2 to the power of n times 2 to the power of k minus 2 to the power of n is equal to 8064. Now if I factor out 2 to the power of n, I get 2 to the power of n times 2 to the power of k minus 1 is equal to 8064. And 8064, this is simply equal to 128 times 63. So I have 2 to the power of n times 2 to the power of k minus 1 is equal to 128 times 63. Now notice I have 2 to the power of n, that's going to be an even number, and 2 to the power of k minus 1, that's going to be an odd number, because 2 to the power of k is going to be even, and an even number minus 1 is going to be odd. And 128, this is even, and 63, this is odd. So now, meaning I can simply set the evens equal to each other, and I can set the odds equal to each other. So 2 to the power of n, this is equal to 128. So let's first go ahead and solve this. If 2 to the power of n is equal to 128, well 128, that's the same thing as 2 to the power of 7. So I have 2 to the power of n equal to the power of 7, and this means that n is equal to 7. Now, we have 2 to the power of k minus 1 equals 63. So if 2 to the power of k minus 1, if 2 to the power of k minus 1 is equal to 63, then all I have to do is simply add 1 on both sides. These two cancel out, and I'm left with 2 to the power of k is equal to 64. Now 64, that's the same thing as 2 to the power of 6. So if 2 to the power of k is equal to 2 to the power of 6, meaning k is equal to 6. So now remember how we said m is equal to n plus k. So in this case, n is 7 and k is 6, so m is equal to 6 plus 7, which is 13. So m is equal to 13, and n is equal to 7. So these are my solutions. Alright, so in this problem, I have 100 to the power of 100 over 50 to the power of 50. So 100 is the same thing as 50 plus 50. So I'm going to rewrite this as 100 to the power of 50 plus 50. And I have this over 50 to the power of 50. So now, an important property of exponents is that if I have something in the form a to the power of m plus n, this is simply equal to a to the power of m times a to the power of n. So as you see, in this case, I have 100 to the power of 50 plus 50. So 100 to the power of 50 plus 50, this is going to equal a to the power of m, so 100 to the power of 50 times a to the power of n. And n is the same thing as m, so again 100 to the power of 50. So now I have 100 to the power of 50 times 100 to the power of 50 over 50 to the power of 50. Now, if I have something in the form a to the power of m over a to the power of, over b to the power of m, this is equal to a over b to the power of m. So in this case, I can rewrite this as 100 to the power of 50 times 100 to the power 50 over 50 to the power 50. And now I'm going to rewrite 100 to the power 50 over 50 to the power 50 as 100 over 50 to the power of 50. So now 100 divided by 50 is simply 2. So now I have 100 to the power of 50 times 2 to the power of 50. Now, if I have something in the form a to the power of m times b to the power of m, this is simply equal to a times b to the power of n. So in this case, I have 100 to the power of 50 times 2 to the power of 50. We can think of a as 100, b as 2, and m as 50. So this is going to equal 100 times 2 to the power of 50. Well, 100 times 2 is simply 200, so I'm left with 200 to the power of 50. So this is my answer. Alright guys, so I'm going to be solving 3 to the power of x plus 1 is equal to 12. So right here, I want to find the value of x. So for my solution, I'm going to first start with 3 to the power of x plus 1 is equal to 12. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 3 to the power of x plus 1, we can rewrite as 3 to the power of x times 3 to the power of 1. And this is equal to 12. Now 12, we can also rewrite as 3 times 4. So now I have 3 to the power of x times 3 to the power of 1 is equal to 3 times 4. Now 3 to the power of 1, that's the same thing as 3, so I have 3 to the power of x times 3 is equal to 3 times 4. So now all I have to do is divide both sides by 3. These two cancel out. Now I'm simply left with 3 to the power of x is equal to 4. Now 4, this is the same thing as 2 to the power of 2. So now I have 3 to the power of x is equal to 2 to the power of 2. So now I'm going to take the log on both sides. So now I have log 3 to the power of x is equal to log 2 to the power of 2. Now if I have something in the form log a to the power of b, I can simply move this exponent b to the front. So this can equal b times log a. So in this case, log 3 to the power of x, I can move x to the front, and log 2 to the power of 2, I can move 2 to the front. So now I have x times log 3 is equal to 2 times log 2. Now to solve this, I'm going to divide both sides by log 3. And these two cancel out. Now I'm left with x is equal to 2 times log 2 over log 3. Now log 2, this is equal to 0.301, and log 3, this is equal to 0.4771. So I have x is equal to 2 times 0.301 over 0.4771. Now 2 times 0.301, that's equal to 0.602 over 0.4771, which is equal to 1.26. So this is my answer. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to multiply two numbers in scientific notation. So we have 5 times 10 to the power of negative 2 times 8.9 times 10 to the power of negative 2. And a number in scientific notation would be in the form a times 10 to the power of n. So as you can see, both of these numbers are in scientific notation because they are in the form a times 10 to the power of n. So let's say we had the number 200. Now, how would we put this in scientific notation? Well, a here, this has to be a number between 1 and 10. This has to be a number between 1 and 10. So we have to change 200 so that it's a number between 1 and 10. Well, 200, if we cancel out these two zeros, we would have 2, right? So that means a here, this would be 2. And now we multiply this with 10 to the power of, well, because we canceled these two out, we went 2 spaces to the left, right? Well, that's going to be -2 because we went 2 spaces to the left. If this was just 2 and we were converting it to 200, we'd go 2 spaces to the right and that would be +2. But because we went 2 spaces to the left, it's going to be -2, 10 to the power of -2. So this is 200 in scientific notation form. Now, to multiply these two numbers in their scientific notation, we're going to multiply our a's and our 10 to the power of n's. 8.9, that would be 44.5. Now, 10 to the power of -2 times 10 to the power of -2, well, this is just 10 to the power of -2 plus -2. Because remember, when we are multiplying two exponents, let's say a to the power of x times a to the power of y, when the bases are the same, all we do is we simply add these two exponents. So this would be a to the power of x plus y. So that's exactly what we did with 10 to the power of -2 and 10 to the power of -2. Now this would equal 44.5 times 10 to the power of -2 plus -2 is -4.